This is reassessment number 3, Newton's second law. A block of mass m1 equals 4.9 kilograms on a frictionless inclined plane of angle theta equals 43 degrees and is connected by a massless frictionless pulley to a second block of mass m2 equaling 3.70 kilograms hanging vertically. Basically, this is just a version of Atwood's machine with an inclined plane thrown in. So, what is A, the magnitude of the acceleration of each block? B, what is the tension in the cord? And C, what is the direction of the acceleration of M2? So what we do is what Dr. Lane always says: draw a picture, get an idea of what we're talking about. So we see mass 1, mass 2 in the inclined plane and the 43-degree angle. Now, because the two masses are joined by a string, we can surmise that the distance by which m1 moves up the plane is going to be the same as what m2 moves vertically downwards, and vice versa. And this is probably going to be true for the acceleration as well. So what we need to do is draw a free body diagram. And here's what we have right here. The x-coordinate being parallel to the plane, and the y-coordinate being perpendicular to the plane. Now, there is no y acceleration, so the components of the forces in the y direction must add to 0. And this gives us n1 minus m1g cosine theta equals 0, or n1 equals m1g cosine theta. Now, this, even though this isn't needed for the problem, it's a really good thing to know. Next, find the sum of the x forces that give m1ax. Now, tension minus m1g sine theta equals m1ax. And the only two unknowns now are t and ax, meaning tension and acceleration. So we draw a free body diagram for the second one. We show that tension's going up as well, and as m2g is pulling down. So the sum of the forces of m2ax is m2g minus t equals m2ax. Really, now all that is left is algebra, because the physics part is done. So first we have to solve for ax. So we take the sum of x forces for m1ax is t minus m1g sine theta, and we add the m2g minus tension from the sum of the forces m2ax equaling m1ax plus m2ax, like I just said. And you get rid of t. So you get m2g minus m1g sine theta equaling m1 plus m2 times ax. Now move ax to one side, and you get m2 minus m1g sine theta times gravity over m1 plus m2. And now we just substitute. So 3.7 kilograms minus 4.9 kilograms sine 43 degrees times 9.80 meters per second squared divided by the sum of 3.70 kilograms plus 4.9 kilograms. And that gives us plus 0.408 meters per second squared. So this means that the acceleration of m up the slope and m1 up the slope and m2 down slope has a magnitude of 0.408 meters per second squared. Now, to get the tension in the string, we just look at the old problem again. So m2g minus t equals m2ax, and t equals m2g minus m2ax, or m2 times g minus ax, and just substitute again. So t equals m2 times g minus ax, or 3.70 kilograms times 9.8 meters per second minus 0.408 meters per second squared. And that comes up with 34.8 newtons. And so that's how much tension is in the string. Now, because the acceleration ax is in a position, can't read my own handwriting. Because the acceleration ax is positive, the block m1 moves moves, oh, my finger covered it, moves up the incline. If AX was negative, M1 and M2 would then move to the left, not to the right as they currently do. I hope you enjoyed this video, and thank you.